And now it's time to implement the client end of the mTLS connection. Similar to what we did on the server application, we'll remove this insecure creds and replace it with its SPIRE secure alternatives. With one difference from the server. For this particular client, we want this client to specifically talk to the server that identifies itself as a cluster 3 demo server and nobody else. And to do that, instead of authorize any, in this instance, we'll use authorize ID, which from its name, you might have guessed that it's an authorizer that you pass the ID to it, and if the ID of the peer doesn't match the ID that you pass, the connection will be rejected. So we'll wrap this credentials one more layer to make it fit into this gRPC dial context call signature like this. And that's the only change we need to establish a secure communication on the client side. Similar to what we did on the server, we'll also extract the identity of the server that we are talking to. But before that, let me add some additional dependencies here from the Go SPIFFE library, which greatly helps using the SPIRE workload API by abstracting its implementation details behind a reusable, intuitive API. So kudos to whoever is maintaining it. So that's all the dependencies we need, I think. And in the send request method of the client, we'll try getting the peer ID from the peer that is hopefully populated after we receive this gRPC response from the server. So if we can get it, we are going to assign the server ID as the SPIFFE ID of our peer. And we also forgot to fetch the source that contains the SVID and bundles. So let's do that real quick here too. Similar to what we did on the server, we are going to get the bundles as a new X509 source from the workload API. And we'll also add a SPIFFE workload API as our dependency here. And that's all that there is to it, I guess. Let's build our application, then edit the deployment manifest of the client. So I'll cheat a little bit and copy the volume and environment part from the server's deployment manifest because they are quite similar. And I think that's all we need for the client. So let's deploy it by doing a kubectl apply greeter client.yaml. And when we get pods, we have our client and server. And when we tail the logs of the client and the server, we can see that they are communicating securely and they know each other's identity, which concludes the mTLS setup between two workloads in a single cluster. And in the next video, we'll take this a step further. We are going to move this client from cluster 3 to cluster 4 in another virtual machine. And we will federate our clusters to extend this mTLS connectivity from within a single cluster to communicating workloads securely using mTLS across different clusters. So see you in the next video to implement this.